As a reminder, perpendicular lines are lines that intersect to form right angles to one another. You can see there's an example already here where we have a blue and a reddish line. They're coming in at a 90-degree angle to one another. What's really important for you to know is that lines that are perpendicular to each other have slopes that are opposite reciprocals. With the example that's graphed there, they also give the equations of the lines. The first equation has a slope of a negative 1/4. The second equation has a slope of 4, or 4 over 1. When you think about reciprocal, that's the flip-flop. And the opposite means one has to be negative, one has to be positive. Let's try out some of the example problems. Number 5, we are looking for the slope of a line that is perpendicular to that equation. First, let's identify what the slope of this line is. The slope is 3 over 2. What would the slope of a perpendicular line be then? Well, that would be the reciprocal, 2/3. And it's going to have to be negative because the original slope was positive. Next problem, number 6. Slope here is negative 4/5. Slope of a line that would be perpendicular to that, the opposite reciprocal, 5/4. The original problem had a negative slope, so your perpendicular line is going to have a positive slope. Number 7, slope of this line is 6. Slope of a line perpendicular, 1/6. This was originally positive. This one is going to have to be negative. Let's look at some more problems. Number 8, we're looking to write the equation of a line that is perpendicular to the one that is given. And it also has to contain the point 0, -2. We're going to first take this equation of the other line, and what we're going to concern ourselves with is what the slope is of that line. The slope is 5. So the slope that we're going to use for a line that's perpendicular is going to be 1/5, and we want to make that negative. We also have the point 0, -2. Let's go ahead, put it in point slope form. Y minus y sub 1 equals m times quantity x minus x sub 1. This would be your x, your y. Make sure you include the subscripts. Plugging that information in, y minus a -2, y plus 2 is equal to slope, -1/5. Ooh, that all kind of ran together. I'll put a negative sign up here. Times the quantity x minus 0. This is still y plus 2. When you distribute this, you're going to end up with a -1/5 x. And then multiplying by 0 or adding 0 on there isn't going to change anything, so I'm not going to write anything after that. Next, I'll subtract 2 on both sides. Y is going to be a -1/5 x minus 2. And that's what we're looking for, that equation. If you come over and I graph this, I'm going to graph it in red. I would start at -2. I would go down 1 and to the right 5. I'll also go backwards here. So you can get the idea of what that line looks like when it's graphed. Let me change colors. I will do the original equation, the other line that should be perpendicular in blue. Start at 3. Go up 5 and over 1. And I'll go back 5 as well. And so this is making sense. They look like they are perpendicular. They look like they're coming in at a 90-degree angle. Let's go ahead and try another one of those types of problems out. Write the equation of a line that is perpendicular to the one that's given. The one that's given, y equals -2x plus 7. The only thing we need off of that is that -2. That means the slope we are going to use will be the opposite reciprocal. We need to make that into 1/2. The original slope was negative, so our slope is going to be positive. And they gave us the point 6, 2. This is an x and a y. We need to find the equation of the line. I'm going to use the second method for doing this. Instead of point slope form, I'm just going to use y equals mx plus b directly. Our y value is 2. Our slope m is 1/2. X is 6. Multiply 1/2 times 6, and you'll end up with 3. I'll subtract 3 from both sides. B is going to come out to be a -1. Don't forget to actually write the equation out. Y equals the slope, 1/2 x, plus b, or in this case it's a -b. I'll subtract 1. There's my equation of my line. You could use point slope form if you wanted to, if you're more comfortable with that. Question 10. A city's civil engineer is planning a new parking garage and a new street. The new street will go from the entrance of the parking garage to Handel Street. It will be perpendicular to Handel Street. What is the equation of the line representing the new street? Let's first find the equation of the line for Handel Street. Now, the graphics aren't the greatest on this. This would be 1, 2, 3, and then this would come out at 4. This is 1, 2, 3, 4, and that would be 5. So the slope here, if you go from 4 to that 5, it'd be down 4 and to the right 5. The y-intercept, where it crosses the y-axis, is at a +4. When you come up with the equation, y equals the slope times x plus 4. When we find our new street equation, we need to know what the slope is going to be. Well, the slope is going to be the opposite reciprocal. That means it's going to have to be 5/4, and it's going to have to be positive because the other one was negative. And the y-intercept is sitting on the y-axis right now, that point that they give you coming out of the garage. And that's at 1. So when you come up with your equation, y is going to be 5/4 x plus 1. And that will be our answer.